Perovskite solar cells. There's a lot of research and development happening right now around new PV technologies, and perovskite solar cells are one of the most talked about areas. Because their efficiency has improved so quickly in a relatively short time, work on bringing perovskites closer to real-world use continued throughout 2024. These cells are attractive because they offer the potential for very high efficiency, lower material costs, and a manufacturing process with a smaller carbon footprint. Several companies, especially in China, have already set up pilot production lines for perovskite PV modules. Some of these modules have started shipping for demonstration projects, but as of the end of 2024, large-scale commercial production hadn't started yet. That said, a few companies have reported important milestones, including passing IEC 61215 and 61730 certification tests. For example, Utmolite announced in February 2024 that its commercial-sized perovskite module, with an area of 0.72 square meters, had passed these IEC tests and received TÜV certification, which was the first and only one of its kind at the time. At the same time, there's also a lot of momentum around tandem solar cell technology, which combines perovskite cells with traditional crystalline silicon cells. This work is happening worldwide. Oxford PV in the UK began small-scale production of tandem cells using M6 wafers, 166 mm, at its factory in Germany. Then, in June 2024, the company announced it had achieved a 26.9% conversion efficiency for a PV module with an area of about 1.6 square meters, based on measurements from Fraunhofer ISE CalLab. Hanwha Solutions, through Hanwha Q Cells, also made progress. The company set up a pilot production line in Thalheim, Germany, back in November 2022, working with the Helmholtz Center for Materials and Energy Research Berlin and other partners. In May 2023, Hanwha announced a $100 million investment to build another pilot line for tandem modules at its Jinshan plant in Korea, with the goal of starting commercial production by the end of 2026. In China, Tongwei Group plans to establish a PV technology R&D center in Sichuan province, which will include a 100 megawatts per year perovskite HJT tandem research line. This project has already received official approval from the Sichuan Provincial Development and Reform Commission. Tongwei also reported achieving a 31.68% conversion efficiency for its perovskite HJT tandem cell in November 2023. Other major Chinese companies are also active in perovskite and tandem research, even if they haven't yet announced pilot production lines. For instance, in June 2024, LNGI reported a 34.6% efficiency for a small-area perovskite CSI tandem cell, measured by EU ESTI. The company also achieved 30.1% efficiency using M6 standard wafers, based on measurements by Fraunhofer ISE. Jinko Solar is working in this area as well, and in May 2024, it announced that its perovskite crystalline silicon tandem cell with an N-type TOPCon structure reached 33.24% efficiency, as measured by CIMIT in China. Overall, research, development, and demonstration of next-generation solar cells based on perovskites has been very active. However, neither single-junction nor tandem perovskite technologies have reached full-scale commercial production yet. There are still several challenges to address, including improving efficiency at the module level, closing the gap between small-area cells and large modules, proving long-term stability and service life, and establishing reliable manufacturing processes. Beyond the technical side, the industry also needs to identify target markets where perovskite technology really makes sense, develop standards for performance measurement and reliability testing, design complete system-level products, and make sure environmental safety and recycling are properly handled. For tandem cells in particular, durability and reliability need to be fully proven before they can be introduced into the existing crystalline silicon market. Finally, advanced 3-5 group technologies, like gallium arsenide and other multijunction cells, are still mainly used for space applications. That said, as crystalline silicon modules continue to get cheaper, their use in space has also increased, especially with the rise of smaller satellites and more frequent launches.